Tämä laite tuossa takana on BepiColombo, seuraava Euroopan avaruusjärjestön suurempi tiedeluotain ja itse asiassa eräs mielenkiintoisimmista tiedelennoista koko maailmassa. Tämä luotain tulee lentämään Merkuriukseen, siis aurinkoa läheisimpälle planeetalle, joka on kooltaan jotakuinkin kuun kaltainen ja hyvin paljon muutenkin kuun tyylinen, paitsi että se ei ole lainkaan kuun kaltainen, vaan siellä on edelleen hyvin paljon mielenkiintoisia asioita selvittämättä, sillä Merkuriusta on käyty tutkimassa tätä ennen ainoastaan muutaman kerran.
So there have been two missions so far. Mariner 10, which had flybys in the 1970s, and then the Messenger mission, which went into orbit and did lots of things. So this time we're going to be sending 3 spacecraft there. We're sending the propulsion module, which of course has no science, and then the European planetary orbiter and the Japanese magnetospheric orbiter. Because there are still many questions which are really unanswered about Mercury. Why does it have a liquid core with a magnetic field? Why does it have volatiles on the surface? How does it have water at the poles? It should have gone long ago. So maybe, the answer to the water might simply be that things have hit the surface over time. Comets, asteroids brought water to the surface, and if you hide them at the North Pole and the South Pole, in the places where the sun never shines, that's one of those little facts about Mercury. People don't realize it has no tilt in its axis at all. So unlike here at ESTEC's day, where it's sunny and warm because we're in the summer and the Earth is tilted in the northern hemisphere towards the sun, Mercury never does that.
Yeah.
So there are places at the poles where the sunlight never gets in, and you can keep icy water, not water ice. You can't keep liquid.
Indeed.
So those are sort of real unanswered questions about how Mercury has the properties it has today, and Bepi's designed to go and solve some of those big mysteries.
Jos kaikki nyt menee hyvin, se laukaistaan matkaan lokakuussa ensi vuonna. Ja ensi vuoden maaliskuussa se lähetetään täältä Euroopasta kohti Kuruuta, josta se ammutaan siis Ariane 5 kantoraketilla lokakuussa 2018 avaruuteen. Lento tulee kestämään 7,2 vuotta, eli tämä tulee saapumaan perille vasta vuonna 2025. Ja syy siihen on yksinkertaisesti se, että lentäminen sisäänpäin aurinkokunnassa on erittäin hankalaa. Paljon vaikeampaa kuin esimerkiksi Marsiin lentäminen. Alusta täytyy jarruttaa, ja sen takia tämä tulee tekemään 1 kerran maapallon ohilennon, 2 kertaa Venuksen ohilennon ja pyörimään vielä muutaman vuoden ajanilla auringon ympärillä ennen kuin se asettuu kiertämään Merkuriusta oikein kunnolla, siis joulukuussa 2025. Luotain koostuu selvästi 3 osasta. Tuolla aivan päällimmäisenä on tuo täytekakun muotoinen japanilainen magnetosfääriluotain, joka tulee kiertämään itsenäisesti Merkuriusta. Sen alapuolella on varsinainen BepiColombon Merkuriusluotain osa, varsinainen tutkimusosa, joka tulee kiertämään myös itsenäisesti hieman lähempänä Merkuriusta. Ja alapuolella on sitten osa, joka kuljettaa nämä 2 yllä olevaa osaa Merkuriuksen kiertoradalle, mikä sinällään on iso homma. Finally we are here. After years and years and years, BepiColombo is over there. What do you think now?
I'm extremely proud and happy to present this status to you today, because we have now solved all our technological issues. We are doing system level testing now, a moment we waited for years, and now you see in front of you the launch configuration, except that we do not have the MOSIF installed on the MMO, but this is something
this back there.
Yes, exactly. Yeah. Something we do extra for you, that you at least have a chance to see the MMO, which is the spacecraft on top of this tower here.
What were the major hurdles, major problems when doing now the BepiColombo?
The major problem was the development of the cells of the solar array. We had some technology demonstration running before, which all did not lead to success, so we had to really start from scratch. We were attracted by significant reduction in performance of the solar arrays over lifetime due to ultraviolet and high ultraviolet conditions, something we had to solve over the years, build the samples, test and test and test and test. Now we are there where we are, and I'm very happy that we can present this. You see on top of the MTM solar array, you see the high gain antenna. to develop the color, the paint, which survives really the heat without deforming, was a challenge. And the complete structure, of course, is we cannot allow that the antenna deforms. Then you lose, of course, in worst case, your link. The gain will degrade anyhow. It goes against the quality of the transmission. We cannot afford this. So this is a very stable equipment, also capable to withstand a certain partial illumination. So if one element is in shadow, the other in the sun, it does not mean that we interrupt intermediately, but of course the deformation has to be kept to a minimum. Also this we managed. I'm also very proud.
We are right now 1 year and a couple of months away from the launch.
Precisely 456 days.
Exactly. So why this day is so important now? What happens after that? Let's put it in this way.
This is, for you, the last opportunity to see the spacecraft in the launch configuration in Europe. After we finish this day here, we are ready to dismount the stack and leave it still electrically connected, that we can repeat all the electrical tests, which we will do. After we have done this, we really separate to module level, really module by module, and do all the separation tests. That means for the MTM, the solar array, the big solar array, the two wings you see. We have to do the alignment, of course, where we have to confirm the stability of the structure we have. For that we have mirrors on board, but the mirrors are only accessible when we have removed all the thermal insulation, for example.
How do you feel working in this kind of project that is really long? Not so long as was Rosetta. It took 10 years to fly. This is 7 years, and launch is now 440 something days from here. I think that when the probe will arrive finally to Mercury, you will be in rocking chair.
It's true. I will stay somewhere on the beach and enjoy hopefully that the orbit injection is successful. No, I hope I will be in ESOC at that day.
Right.
Because they take over operation. Of course, for me it's clear, but I will be retired. This is quite evident.